Hello everyone, thank you for joining us today. My name is Jean-Simon and I work with the additive manufacturing team and 3D scanning team at Javelin as a strategic account manager for Quebec and Eastern Canada. So I'll be with you today to present you advanced manufacturing overview. So I will present different technologies, application, and I'm pleased to be able to present you as well new products. Just to present our additive background, so we have over 30 years of combined additive experience, and with the design solution as well, combining with the additive manufacturing and 3D scanning, we have more than 55 years of combined years of serving the design manufacturing communities across Canada. Our focus is really to focus on the application. So we're really focusing on finding innovative application of the technology to drive the development of new capabilities. In terms of how we help our clients, so we're partnering with innovation leaders to adopt 3D printing and 3D scanning. We also have years of experience to tailor to custom tailor solution to your unique application. We also have different types of solutions from hardware, software, materials, and also support. So we're able to support our partners and also companies that we're working with all across Canada. We also have different types of solution depending on the professional budget in terms of printers and scanning. So we have a solution from $12K US to $500,000 for printers. And we're also able to provide different types of software which are quick to learn and powerful enough to keep using. In terms of just to present our partners and the companies that we're working with, So we are our flagship partner is Stratasys for plastic printing. We also represent Desktop Metal and Exact Metal for economical, office-friendly metal printing. We are also partner with post-process for printing, support, removal, and part finishing. Artec 3D is our partner for 3D scanning. We also have our support team with the Full Care and Full Care Plus where we're able to support our clients with their hardware. And we also have our professional services for printing and scanning, where we're able to provide services and also produce parts and support for different types of application. And of course, we are also partnered with SolidWorks. Just to present some industries that we're working with. So additive manufacturing is present in nearly all industries and truly is a great fit if you're making, assembling, or designing any form of product due to the lack of design limitations. So we're highly involved with education. We're working with over 200 schools across the country, supporting them with teaching and also research and development. We're also working with defense, commercial product, consumer products, aerospace, medical, just to name some of them, and also automotive. In terms of the today's manufacturing challenges, many challenges which manufacturers face are common across all industries. Upper management and investors always want more product, which is higher quality than yesterday. Quality is crucial to a successful business and product. And any kind of mistake, especially relating to a tooling, can be expensive not only to fix it, but more importantly, from the lost production time. And most importantly, focusing on employee safety will always drive innovation and generate creative new ways to accomplish your goals. So that's some of the manufacturing challenges that are common today. In terms of the industry trends and what's fueling the growth, maybe just to give a short story. So there was a huge patent expiration in 2009, which enabled the introduction of low-cost solution at the hobby level. So at that time, there was a bunch of predictions of traditional part manufacturers, warehouse, logistic companies who would be significantly disrupted. But in reality, 3D printers were used mostly to print plastic prototype, and home 3D printers could be fun, but the items that were made were almost never of functional value. So today what we're seeing is that 3D printing is still highly involved for prototyping, but because of the new materials, we now have access to produce full strength parts, and also functional prototyping tooling as well that I will be able to present later on. So in terms of the additive manufacturing technology preview, so I will present to you some of the technology that we're working with. With Stratasys, we have the FDM technology that we are really using a lot. So that this technology is using thermoplastic. We also have the polyjet technology with UV curable resins. With desktop metal, we have the FDM for metal printing, which is also called bound metal deposition. And also we are using the binder jetting technology as well with metal powders. And with exact metal, we have direct metal laser sintering with metal powders as well. So with Stratasys, with the FDM technology, so we're proposing different types of systems. So we have the engineering series, the advanced manufacturing, and also the advanced manufacturing for 450 and F900. We have solutions that fit for a different budget. So from 12K to 500K, and on each systems, it's not necessarily the same material that we have access. And in terms of the build envelope, it will also vary. So with the F123 series, it's from 10 per 10 per 10, but we can go up to 14 by 10 by 14 with the F370, which also give access to engineering materials as well. If we move forward with the Fortis 450, the build envelope is 16 by 14 by 16. It also give access to engineering materials, but also high performance materials as well, and also standard materials. And with the F900, we're able to produce parts up to 3 feet by 2 feet by 3 feet for a bigger production, and also bigger parts as well. And so basically we have different solutions available depending on the application and also the professional budget. And the FDM technology is a well-established technology, and it has been on the market for over 20 years now, and it was also founded by Stratasys. If we take a look at the polyjet technology, that's also a technology that we're offering with Stratasys. So we have the desktop printers with the Object 30 Pro V5, and also Object 30 Prime V5, excuse me. We also have the Precision series with the Stratasys J826 and J55. And we have the production series with the J850 Pro and Prime. So from one printer to another, the material will also vary, the build envelope as well. If we look at the desktop printers, it's for a single material, but if we move forward with the Precision series, we have access to multi-materials, multi-colors, and also multiple textures that we're able to print at the same time. And moving forward with the production series, we have access to faster system with a bigger build envelope. So it's the polyjet technology is for extremely high quality printed parts in full color. We also have a digital anatomy printer with accurate material properties to help mimic human tissue. That's something that is also really useful for pre-surgical training as well. So with exact metal, using the direct metal laser sintering, it's a good small footprint option that allows companies to enter into direct metal laser sintering printing. It's affordable. We're looking at high part density, nice surface, high resolution and tolerance. So it's perfect for complex geometries, and we also have access to different types of materials. If we take a look at some additive manufacturing applications, so as I mentioned before it was really more prototyping that we had access with additive manufacturing, but today what we're seeing is that we are also being able to be highly involved with rapid prototyping, with concept modeling, functional prototypes, but also in terms of manufacturing with manufacturing heads, forming tools, and end-use parts. So if we take a look at concept models, so it's a great opportunity to print a primarily designed to test the fit and form. Adjustments are easy to make early in the design cycle and could save weeks or months from a later design stage. It can help decision makers to visualize the concept which is being proposed, and we have different enablers, which are excellent tolerance, extensive material options. As you can see, we have transparency on some of the parts here. With Vero Ultra Clear, this is one of the materials available with the PolyJet who are transparent. High resolution models, and also realistic material performance. Also, in terms of prototyping, so now we're also looking at advanced prototypes. So we're able to do functional testing and simulate real-world condition because of the materials and the high-performance materials that we have. Thermoplastic stability is also something that is one of the enablers as well. Accurate and excellent repeatable tolerance capabilities also. So the high quality materials combined with accurate first time right printing creates reliable parts, and this is why we're able to now do functional prototyping. If we take a look at an example here, so we will look at GVL Poly, who use the F900 to shorten their development and testing time. So it's a rotomolding company who focus on the agriculture sector. So what they did is that they decided to use the F900 of Stratasys that I presented because of the huge build envelope, and they were looking to test big parts. So they decided to use the ABS M30 for fit assembly tests. They were looking at a high accuracy and stable material, and end use and field testing as well. So they tested dozens of variation of wear point in one harvest season, and wear point is in constant contact with the ground. So by using the FDM technology and ABS M30 with the F900, they were able to reduce time to market from between 3 and 5 years to one harvest season. Also, if we're looking at another type of application, so with toolings and jigs and fixtures, in the tooling area, especially with jigs and fixtures, there are so many applications which are fantastic fits for additive manufacturing. So as you can see, for production and assembly, transportation, quality control, and expansion, and packaging and logistic as well. This is also a great use case for a new material introduced on the engineering grade F123 line of printers with the ABS CF10 that I'll be able to present later on. So just to share an example, so this is a very complicated build for the tooling shop and requires special capabilities such as an aluminum welder, complex angle cuts, and accurate locating over multiple assembled and welded pieces. So they were facing different type of challenges with complex angles on frame, ergonomic concerns and handles, and remote handled valve as well. And the assembly weight was 12.5 pounds initially. So what we did is that we did what we call a DFAM, which stands for Design for Additive Manufacturing, to make sure that the parts would be adapted for 3D printing to make sure that we will have a successful application. So now if we just take a look at some numbers and at the final results, so we have an extremely lightweight fixture which is strong enough to accurately move parts, and the design is kept clean by routing pneumatic hoses through the structure. So we were able to reduce the build time, the assembly time as well, the weight of the part, and also in terms of the cost. So just to give a quick comparison here, so we were able to reduce by 30% the weight of the part, 50% saving in cost versus against the traditional weldment, 30 hours of build against 5 to 6 weeks through the fab shop. So there was a great, this is a great example here of how additive manufacturing is able to help. Just to give another example as well, so in terms of jigs and fixtures, so as you can see, it could be for different types of application, badge template and apply headlight aiming, just to name a few of them. So the beauty of additive manufacturing is that it allows us to create customized tools with tailored designs. Also, in terms of fabrication, tooling could be something really helpful as well. Excuse me. Some examples are sheet metal forming, composite layup tooling, thermoforming, injection molding as well. So it's a great opportunity to build a tool while waiting for a final metal design. Allows to check for design mistakes. It's applicable to many industries as well. And we're able to get a final part with proper material properties as well. So just to share an example here, once again, of a part. So we have a composite layup tooling. We use Ultem plastic, which is a autoclave, stable and capable of being used for composite molds here. So that's one example that I wanted to present. If we take a look at another use case, so Piper aircraft reduces the cost and lead time of hydroforming tool to build a personal jet. So they were not able to print FDM parts in 10 minutes, while it took them hours before that. So just take a look at this example here. So they were producing hundreds of aluminum structural components, and some of the parts were under frame components, gussets, brackets, skins, and they were also looking at metal forming, drill and trim fixtures as well. So they decided to explore the FDM technology, and they were looking at different types of material, and depending on the pressure required, many different materials options were available for them. So they explored the PC, which is the polycarbonate, which it could be resistant up to 6,000 PSI, and the Ultem 9085 up to 10,000 PSI. So they were able to waste less material, and no operator attendance as well was needed. They were able to print parts in 10 minutes against 4 hours, and they were also able to reduce their costs as well. So this is another example where additive manufacturing was really useful. And you can see on the image we have the FDM parts and also the aluminum part that they were using before. In terms of end-use parts, so I would say that the sweet spot is really when we're looking at complexity in terms of the design, and at a low quantity, so low volume production, looking at rapid tooling, and specialty and end-use parts as well. So just to give more details about that, so in terms of end-use parts, the direct benefits are lower costs, shorter lead times, and the indirect benefits could be design freedom, change freedom, mass customization, part consolidation, just to name a few of them. And also, as an interesting side note, we recently delivered a course to George Brown College for prosthetics and orthotics programs. So we taught the second-year student to 3D scan the lower legs and forearm, design and 3D print the orthotic device in nylon 12. They then fit the device to their fellow student, patient, and then one student went on a 4-kilometer run with their ankle-foot orthotic device. So this is a scene that as the possible future for the prosthetic and orthotic device industry. Also, just to give another example here, so Airbus is a great example. They printed over 1,000 of 3D printed in-flight parts. So we also have materials who are certified for in-flight parts. And also with one of the printers, we're able to produce directly out of it also in-flight parts that are certified FAA and AICS for aircraft interior certified solution. In terms of the additive manufacturing materials overview, so we'll present some of the FDM material. So we are offering different types of materials who are available on different system, and depending on the system, we have access also to different colors as well. So essentially the same plastic pellets feedstock as used in injection molding. So depending on the model materials, we have access to various colors as I mentioned. And one other thing is that the specialty product, including soluble support material, it's perfect for complex geometry. So I will present you some of the materials. So the first one that I wanted to present is the ABS CF10, which is the new material recently launched by Stratasys, which is carbon fiber reinforced. So the image that you can see here is a pipe welded fixtures. So the ABS CF10 is a carbon fiber reinforced ABS composite that would enable you to produce the strongest, stiffest, and lightest jigs and fixtures tools and production parts, and enjoy significantly reduced lead time and costs. So this material is 50% stiffer and 15% stronger than ABS, and it's a strong, stiff, and light materials that is available on the F123 series for the F170, 270, and 370. One other material that is also really popular and well known is the Ultem 1010 because of its mechanical properties. So this is the highest temperature resistant material that we're proposing with the FDM technology. It's a biocompatible material as well with the ISO 10993 certification. USP Class V, it's also certified for food contact. It has high tensile strength, and it could be resistant to more than 210 degrees Celsius as well. So it's good for many industries like the aerospace, industrial, medical, food packaging, just to name a few of them. Also, we have the Entero 808 that I wanted to present. So it's a high performance chemical resistant material. It's good for ultra low outgassing and high heat resistant as well. So we're seeing this material a lot in the automotive, aerospace, and industrial industry as well. Just as an example, we were working recently with a automotive customer, and they were looking at a pump holder ring adapter, and it needed to be resistant to ethanol and gas, and the Entero was the great solution for them, and it was a successful application with this material. Also, we have the 912 CF, which is a carbon fiber filed thermoplastic. So it's the material with the highest ratio and weight resistant of FDM materials. So just to give you a quick comparison against other materials that we have. So as you can see, the highest it has the highest tensile strength and flexural strength of all of FDM material here, and it's a great material as well for a different type of application with great mechanical properties. So if we compare the 912 CF from FDM and Stratasys against competitors and with the different process with SLS, what we can see is that 25% of improvement in strength over SLS composite material, and also 100% improvement in stiffness over the SLS composite material. So it's a material with great mechanical properties. So I wanted also to present you new products as well. So the first one is the H350 from Stratasys. So this new printer is using the SAF technology for selective absorption and fusion, which is a new technology launched by Stratasys. So how it's working is that we have a layer of powder. A layer of powder is deposited by a counter rotating roller. Then we apply an IR absorption fluid that is selectively jetted onto the powder by using a piezo print heads. And then a IR lamp passes over the surface, causing the printed area to absorb sufficient energy to fuse the materials. So this is how Stratasys decided to propose the H350 under the SAF technology. So the benefits of this technology and of this printer will be for production of high volume, cost per part that will be very low, complex geometry, and also for end-use parts. So the industry that that will be using this technology mostly will be the service bureau, consumer goods, commercial goods, and also automotive. One difference with also this technology with similar technology that we're seeing on the market, and also similar products, is that it only uses one liquid, and other companies will use more liquid, so it's more costly, and also it's also more complicated to operate, and it takes more time as well. So that's one of the great difference. And the other thing is the temperature control as well. So it will allow to have access to a better repeatability and accuracy as well, which is something that is lacking currently on the market. The other product that I wanted to present is the F770 from Stratasys using the FDM technology. So this new product will be a perfect solution for great, large, and complex and functional parts. Once again, it will have a heated chamber for a better reliability and repeatability. It will be a cost-effective solution, and it will be good for strong parts as well. It will be a good solution for prototyping, manufacturing heads, and also surrogate parts. And one difference with this technology and this new product is the fact that we will be able to produce a part with accuracy and repeatability. So that's also something that it is lacking with the solution that are available on the market, and also that it will be also a cost-effective solution, because the solution available on the market are also really expensive to be able to produce larger parts, but the F770 will be an affordable solution as well. In terms of 3D scanning, so we also have different solutions. So we have the Space Spider, EVA, Leo, Micro, and Ray. They're all using structured light source, and we have different solutions for different needs as well. So the EVA is good for a medium object up to a small car. The Space Spider it has a twice better accuracy with more precision for a small object up to a size of a small engine block. We have the Wire, which is the Leo, which is a wireless solution with an integrated screen. We don't need a computer to scan. It can scan also bigger object than the EVA. We have the Micro, good for the smallest objects you can scan, 10 microns. And we have also the Ray for larger objects, and it can scan up to 110 meters away. And as an example, we can scan airplanes and buildings. In terms of the applications, so 3D scanning fits into many applications. Javelin has worked with companies to ensure their success with scanning and to provide our scanning services as well. So this is a couple of applications where we see a great use of 3D scanning, and where the Artec solution is a perfect fit. And then, so why we decided to be partner with Artec is because with their solution, it is extremely versatile. We're able to scan a broad range of objects with the Artec solution. iframe rate capture as well. Highly accurate fuse model. No requirements for consumable targets. So this is also a great difference. Most options can be battery powered, and we can combine scan from multiple scanners to get an extremely accurate section on a large part as well. So they are all reason why we decided to be partner with Artec, and why we believe in their technologies and the product that they're proposing. Thank you very much for your attention and for listening. If you have any questions for us, feel free to reach out, and we'll be more than happy to help you and support you for your project and application. Thank you.